This is a review of Chapter 6 for 7th graders, which the focus is equalities, inequalities, and graphing on a. So a couple symbols that are important to remember. This is the equal symbol. That's pretty obvious. Less than or equal to, greater than or equal. We are pretty good at graphing or showing one-step equations. Like if we have 4 times a number equals negative 16, we follow the rules that whatever we do to the left side, we have to do to the right side. Left side, right side. So, and we also want to work backwards. So if we want to undo multiplying by 4, we have to divide by 4. And then the result would be negative 4. And if we wanted to graph that on a number line, we just have to put 2 points on the number line and then draw a dot at negative 4 to show that that's the value that makes that a true and accurate value for n. If our equation had been 4n is greater than negative 16, again we follow the same idea, keep left side, right side, divide both sides by 4. We keep the same symbol here, and this results in n, and negative 16 divided by positive 4 results in negative 4, but our symbol is now greater than, so we can put the negative 4 and the 0, but we have to show that the values that make this true are all greater than negative 4. We don't want to include negative 4, so we draw a circle around that and we go this direction. And we put the ray symbol in here so we know anything greater than negative 4. Just another example of that kind of problem. Suppose it would be the number plus 8 is less than 3. So if we wanted to solve this one, we have to undo adding 8, so we subtract 8. We can use, if we have 3, I think I'll write it a different way. If we have to do this 3 minus 8, we can follow the keep, change, which would mean keep 3, make it add negative 8. And it's plain that we have 5 more negatives than we do positives. So n would be greater than negative 5, and the solution for that would look like 0, negative 5. I'm sorry, that's a less than negative 5. And we go, it doesn't include negative 5, and we go this direction. We might get a statement that says the number that we're thinking of is either greater than a certain number like 4, or maybe the number is less than 2. So there are 2 conditions here, and the end points of the conditions are the 2 and the 4, so we put those on the graph. We note that both of them do not include the end points, so there's going to be circles here. And then just it doesn't look much like an n, so it's make it look more like an n. We just take each statement independently and graph it. N is greater than 4 would go this way. N is less than 2 goes this direction. So that's the solution for this compound inequality. More work involved in something like that, we might say that 3 times the number is less than 12, and the number plus 2 is greater than 14. So when we solve this, we find that the number is less than 4, or, should have put an or in there, then we have to subtract 2 to find the answer to this one, or the solution. N is greater than 12. So our 2 conditions are the numbers, it's either less than 4 or greater than 12. So we put a 4 and a 12. Doesn't include 12, doesn't include 4. Less than 4 goes this direction. Greater than 12 goes this direction. One of the kind of problems that we had difficulty with was the compound inequality that was an and statement. Like the number is less than 12, and the number is greater than 5. So when we graph this, we just graph the separate conditions. We know that 5 and 12 are going to be, I'm going to put equals, less than, the number is less than or equal to 12. And actually, there's a way we read this. is to say, start in the middle and read the number is less than or equal to 12, and the number, now we're reading in the opposite direction from which you normally read. We normally would read going left to right, but we start in the middle to help us make sense of this compound inequality and say n is less than or equal to 12, and n, and because we're reading in the opposite direction, we assign the opposite. This is the less than or equal to symbol, but we read it as the number is greater than or equal to 5. And that helps us know what to put on our diagram, because these are our endpoints, 5 and 12. We know they're included, so we're going to put dots at them and 12. And if it's less than 12, it goes this direction. If it's greater than 5, it goes this direction. So the result of this kind of compound inequality is a line segment. When you have a compound inequality that might have something like the number divided by 2 is less than, let's say, 10, but greater than 4. And to solve this one, you can split it apart, but I found when we worked with it in class, it seemed easier for everybody if we just thought about what do we have to do to undo dividing by 2, and do that right here, and then do it to 10, and then do that to 4. So what we have to do to undo dividing by 2 is to multiply by 2. And we use the dot to signify multiply. And I have to do that here, and I have to do it here. Then I write the results. 2 times 4 is 8, less than. Then n divided by 2 times 2 leaves us with n, and that's what we want to get. We want to get we don't want to know what half of n is, or n divided by 2, we want to know what n is. And this would be 20. So the number is less than 20. Goes this way. I should have put a circle there. Goes that direction. And the number is greater than 8. Goes this direction. And that should be a circle again. I didn't mean to fill that in. I'd erase that and make it look a little cleaner. So this is the bold part. And this is the solution, all the stuff right in here. Another skill that we want to make sure we're pretty good at is looking at the solution of a problem and saying, well, where did that come from? How would I describe that? So if we have 7 and 20, and we have this line segment, we want to be able to say that the number that we're thinking of, just start with the n to represent this number, and think how it compares to 20. Whatever it is, it's less than 20, but whatever it is also greater than 7. One of the keys to helping you get this correct is that start with a symbol that you're pretty sure you have right, which would be, to me, it's the number is less than 20. So I start with that, and I know I have to use the exact same symbol over here, with the exception that it might be less than or equal to, but if I have the less than symbol here, it has to be the less than symbol here. You don't ever mix them up and do something like this. It's not mathematically correct, and it won't make much sense to do that. Something like this, going this direction, and going this direction. I don't even have to assign the values yet, because as soon as you see something like this, you'll know that it's an or. There's a space in the middle, so we'll call this -6, and we'll call this 50. So the number is either greater than or equal to 50, and then we just use the connecting or. The number is, and here you can mix your symbols. You can use less than or equal to -6, and that's how you describe this section. And that's there are more problems than this on your test, but that's sort of a quick overview of the kind of things that you'll be responsible for.